We're going to go through mostly the odds. I did accidentally mess up the numbering at one point, so that gets a little weird, but we end up back on the odds, so it's fine. But we're going to look at each section, talk about what we need to do. This is very, very similarly laid out to how the test will be laid out. Obviously, the test is not that long. The test ends up being longer solely because some things have multiple parts, but the multiple parts aren't necessarily long, okay? Like we're able to get through everything in the review during class today, so I'm not worried about it. So for number 1, we have to determine whether or not it's a function and the domain and range. So is that a function? How do we know that's a function?
There's only one of each x.
No repeat inputs. Okay, so we're going to do our domain. Domain is our x's. Whenever we have a list of points, okay, we use a set to write our domain. So we'll do squiggly bracket, then we just go smallest x to biggest x. So it'd be -7, -4, -2, 0, 1. So if ever we have a list of points, whether it's in a table, a bunch of points on a graph, a list of points, that is how we write domain. Okay, range. That is our y. So again, we're going to go smallest y to biggest y. What is the smallest y? -2. Do I need to write -2 there 3 times? I can just write it once. Okay, then 3, then 5. It won't be wrong if you write it more than once, but you don't have to.
Will you want if you don't write it in order?
No. All right. For number 3, is number 3 a function?
No.
Yes, it is a function.
It is a function. Because is there any repeat inputs? No. Okay. So our domain, we're going to list out our x values. Okay. So what is our x values? -4. -1. And 5. And then we're going to do our range. Smallest y value, -7, 0, 1, 2. All right, now we're going to go to number 5. Okay, if we have a graph, how do I determine whether or not it's a function? Vertical line test. So to pass the vertical line test, it can only intersect a vertical line one time. If I draw a vertical line on top of that vertical line, the entire line intersects. That's a lot more than once. Okay, so does that pass the vertical line test? It is not a function. All right, now for the domain. That line only has one x value. What is it? But our range is the entire line. Anytime we have an entire line, so a continuous line, right, we have to use interval notation. So does this graph ever stop going down? Does this graph ever stop going up? So it goes forever in both directions. So what would that mean? What is forever down? Negative infinity. What's forever up? Infinity. All right, for number 7, is that a function? It is a function. Because it passes what? Because if I draw a vertical line, how many times does it intersect? Once. So it is a function. Now, for domain, The leftmost point of this graph has an arrow. Does that mean it ever stops? So what would be to the left forever? Negative infinity. What would be to the right forever? Okay, then for range, does this graph ever stop going down? So what's down forever? Then what's up forever? No. The one of these that would be a little different is number 4. Okay, is number 4 a function? It is a function. Okay, how this one is a little different. If I look at domain, does this graph ever stop going left? So that would be negative infinity. Does it ever stop going right? So positive infinity. But range, does this graph ever stop going down? What's the lowest it goes? And so if it's not open, we use a bracket. Does it ever stop going up? No, so that would be a parentheses. Okay. It can be a combination of numbers and infinity. But that is, I'm going to leave y'all to that. Now, we're going to go and look at number 9. So number 9 is just points on a graph. Okay, it's a bunch of points. So does that pass the vertical line test? So that means it is not a function. Where does it not pass at? Yep, at -1 it fails, and +3 it fails. So when we do the domain of this, we have a bunch of points, right? If it's points, whether on a graph, in a list, or on a table, we just do a set of points. So we're going to start at the left. What is the x value of this point? -2. What is the x value of those points? -1. What's the x value of this point? 1. X value of this point? And of these points. Then for range, we look at the y values of the points. We go bottom to top. So start at the bottom. What is the y value here? Here. So that's the first 2 points, -4, -2. What's the y value here? The y value here. Then okay, because it is a bunch of points. Now we're good to go ahead and flip to the back of this page. We're going to look at number 10 all together. So meteorologists recorded the total January snowfall for several cities. So A tells us when the input is the city and the output is the snowfall, is it a function? So that's saying the city is X, snowfall is Y. Is that a function? Yes. Because each city can only have one total snowfall, like total amount of snow. Each city has one total for January. Okay, but B says if we switch them. So if we make city the output and snowfall the input, is it a function? Why not? Because of what? Because two cities can have the same total amount of snowfall, right? All right, now we're going to look at evaluating functions. So we're going to go to number 11. So for number 11, it gives us a function f of x, and it tells us to find f of negative 6. What does that tell me x is? Negative 6. What do I need to do with that? So we're going to do f of negative 6 is equal to negative 2 times negative 6 plus 3 plus 1. Now, you have some options. You can do it in your head, do it in pieces, or put it in a calculator. I do not care. If you put it in a calculator, use parentheses correctly, okay? Because if we did this in pieces, negative 6 plus 3 is what?
Negative 3.
Negative 3 times negative 2 is? Negative 3 times negative 2 is positive 6. Plus 1 is 7. All right, now we're going to look at the next one. This is where my numbering got a little weird. I just skipped a number. So for the next one, we're going to look at f of x is equal to negative 2x squared minus 4x plus 2. Find f of 3. What is x? 3. What do I need to do with that? So we're going to get f of 3 is equal to negative 2 times 3 squared minus 4x plus 2. I did something wrong. What did I do wrong? Got it. Put it in there too. It has to go in everywhere there's an x. So we can either use our calculator or we can use our brains. What is 3 squared? 9. What is 9 times negative 2? What is negative 18 minus 12? Negative 30. Plus 2 is? Negative 28. All right, now we're going to look at 14. How is 14 different than the one we just did? This is f of x equals 23. So does this mean I need to plug something in? This means I need to set f of x equal to it. So we're going to do 23 is equal to 7 times x plus 2 minus 5. So what do I need to do to solve that? Distribute. So we're going to have 23 equals 7 times x is 7 times 2 is, then we have minus 5. Do we have any like terms?
Yeah.
What is 14 minus 5? So we get 23 is equal to 7x plus 9. What do I do from there? Minus 9 on both sides. What is 23 minus 9? Equals 7x. What do I do from there? What is 14 divided by 7? Equals our x. And you will have more room to do that if that is what the problem does. (16) We evaluate using a graph. So for 16, we are looking where x is negative 4. So we're going to go to x is negative 4 and find the point. What is the y value when x is negative 4? Negative 3. On the test, all of your graphs will show all of the grid lines. That will have a grid line there for negative 3. Okay, because that is what's right there. Now, 18. Okay, 18's problem is on the next page. So we're going to write that at the top of that graph. So this one has f of x is equal to 1. So does that give me x or y? That's giving me our y. So it's saying when y is 1, what is x? So I'm going to go find where y is 1. It's right here. So I'm looking at these 2 points. What is x when y is 1? 1 and 3. All right, then 20 asks us to evaluate from a table. Okay, so it gives us x or y. X. So when x is -4, y is -2. Pretty much for the entire first half of the test, we're not doing a lot of calculations. We're doing calculations for a part of the evaluate. For the most part, we're just looking at a graph saying, is it a function and where the point's at, right? Not too bad. So I want us to go ahead and look at 22. So 22 is a phone's battery percentage, B hours after T, or B after T hours of use, okay? So our function is B of T, right? That tells me my input and my output. My input is what is inside the parentheses. So my input is T hours. Then my output is the function itself, so B of T. What does B of T represent? Battery percentage. So that is our battery percentage. Okay, that tells us that part. We will use that for all of the context questions. So A, it says find B of 3. What does that tell me we need to do? Plug in 3. So we're going to do B of 3 is equal to 100 minus 12 times 3, which that is the same as 100 minus 36, which is 64. And then it says, what does this mean? So in context of that question, so after 3 hours, the phone battery is 64%. Okay, so when it's written like that, that tells us we need to plug in. It's changing the input. But C says, when will the phone's battery reach 40%? That's giving us the output. That's saying equals 40. So we're going to do 100 minus 12T equals 40. And solve it. How do I solve that? Well, there's nothing to distribute. Minus 100. So negative 12T equals, what is 40 minus 100? Divide both sides by negative 12. T is? So that means what? 5 hours to get to 40%. This is not a very good phone battery. But honestly, that is about where my phone battery was at before I got a new phone. So it was not good. It would be dead by the time I got home. It was awful. Oh, and we already identified our input and output. So our input is T hours. Our output was B of T, which was our battery percent. Then we're going to do 23. So for 23, let P of T represent the number of people waiting in line at a smoothie shop. So P of T is the number of people in line. And then T is minutes after opening. So our input is what? Remember, our input is what is in the function. So T minutes. Then our output is P of T. What does P of T represent? Mm-hmm. All right, so if we have P of 0 equals 3, what does that mean?
After 0 minutes, there's no more in line.
After 0 minutes, 3 people are in line. When would 0 minutes be? At opening, right? So as soon as the door is opening, 3 people walk in. All right, P of 10 equals 12. Mm-hmm. So after 10 minutes, there are 12 people in line. All right, what about C? It's P of 15 is greater than P of 5. Yep, more people after 15 minutes than 5. If you answer these slightly differently, as long as you are getting the gist of what it means, you are good on the test. Like I'm not looking for a specific sentence. I'm looking for you to say that it doesn't matter if you say more people after 15 minutes than 5, or at 15 minutes there are more people than 5 minutes. 15 minutes has more than 5 minutes. Like, as long as you say what it is, you're good. You don't have to say it in a specific way. So for D, P of 25 equals P of 30. Yep. So the same number of people at 25 minutes and 30 minutes. Do we know how many people are in line? No, just that it's the same. And then we are going to flip to 25. Okay, 25, 26, and 27 are all identifying the pieces, okay? We are going to do 25 and 27 together, okay? So we are going to start with domain, okay? Remember, domain is our X values, okay? And we are looking from left to right. So our graph, what is the leftmost point of our graph? -5. And that is a solid dot, so that means bracket. And what is the rightmost part of our graph? Now, range, that is our Y values. And we are looking bottom to top. Yes. So you only list them out when you have a bunch of points, when you have like a list of points. If it is a line, you use an interval. Okay? Because is there any way I can, so in between 0 and 1, there is 0.1, 0.2, 0.3, 0.4, 0.0002, 0.0005, 0.12345. So there's no way we can list all of those decimals, so we use an interval to show all of them. So what is the lowest Y value we have? -7. Now, is there an open circle anywhere down there? So that means we use a bracket. Okay, what is the highest Y value? 5. Now, when we do maximum and minimum, okay, we are just looking at the y. So for maximum values, we're looking for the max y. What is the max y? What is the min y? For our intervals, okay, we look at our x values and we do an interval from left to right and we use parentheses on that interval, okay? So we're going to start with increasing. So on this graph, when does it increase? From 2 to 4. Okay, so we would write that first interval from 2 to 4. All right, now on that, is there anywhere else it increases? Yeah, look, it's also increasing from 1 to 2. So you could write that as 2 separate intervals, or you can just go from 1 to 4 because that entire place is increasing. If you did from 1 to 2 and then from 2 to 4, you would not be incorrect. Okay, you can do that, but you can also just do one big interval as long as it's touching, as long as the entire thing is going up. Because if I was to just go increasing, 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 we're good. But here, it's decreasing, constant, increasing. Okay, I can't just switch. If it switches what it's doing, you have to do separate intervals. If it doesn't switch, you're good. So now we're going to look at decreasing intervals. So for decreasing intervals, where is that at? So, yep, it decreases there, and then but it keeps decreasing till you get to -3. So we can do -5 to -3. Is there any other places on that graph that decrease? Where? 4 to 5. How do I connect two intervals? So from 4 to 5. Then we are going to look at constant intervals. Do we have any constant intervals in this graph? -3 to 1. All right, now, for x-intercepts and y-intercepts, both of those use a point. Okay, when we do a point, it is the x-coordinate, comma, then the y-coordinate. So for our x-intercepts, we are looking where it crosses the x-axis. Now, on your test, you will not have to estimate where that's at. On these, you do, just a little bit. You have to see where it's at. So if I look here, roughly where is that point at? -3.5, comma 0. Okay, but the next one is where? 3.0. And then that last one, we're just going to say it's at 5.0. On the test, though, you do not have to estimate. It will be where they are. Okay, now for y-intercept. Okay, where is that at? And how do I write that as a point? 0, -7. Okay. Now we're going to also go over 27 together. So we're going to leave 26 for you, and we're going to do 27. Okay, so for 27, what is our domain? -7 to where? -7 to 7, parentheses or brackets. Okay, for our range, It is -5 to 4. Parentheses or brackets. So as long as it is not showing us an open circle, we use brackets. Okay, now for our maximum values. That is just our y value. So what is our max? What is our min? -5. For our intervals, remember we look at x from left to right. So for increasing, where is our graph increasing? -2 to where?
Oh, wait, no, mine's to 1.
-1. Yep. And then we do have another one. Where is our other increasing interval at? 1 to 3. Okay, then we're going to look at decreasing intervals. Where do we decrease? Yep, -6 to what? Not quite to -2, it's at negative. Yep. Then we're going to U. Where's the next one at? Or we use X, so -1 to 1. And then we have one more from 3 to 7. Now, how many constant intervals do we have? 2. So the first constant interval is what? -7 to -6. What is the next constant interval? -3 to -2. Okay, now we're going to do our x-intercepts. How many times does this cross the x-axis? A lot, right? There's 5 different places. So we're going to start on the left and just go from there. So -4.5 to 0. -2, 0. Zero, 0. Is that where y'all would say that's at? 2.5, 0. And 7, 0. Then our y-intercept. Okay, where is our y-intercept at? 0, 0. All right, now we're going to look at some more word problems. So, you will not have more than one of those on the test. You will have one of those. That's it. Okay. And it's not going to have 12 intervals of decreasing or increasing. It's probably just going to have 1 or 2. Okay. So for 28, you have one in your notes very, very similar to that. So we're going to skip that. And we're going to look at 29. So for 29, the function r of t represents the height in feet of a roller coaster car above the ground t seconds after leaving the station. So first, when is r of t increasing? Yep. 0 to 15. Anywhere else?
Yeah.
Where? 65 to where? So we have from 0 to 15 and 65 to 80. All right, the intervals where it is decreasing. Where is the function decreasing?
40,
And where else?
80 to 120.
Then we have a constant interval where it's at a constant height. Where is that at? 40 to 65. Then it asks, what is the maximum height? What is the maximum height this graph reaches? 360 feet. And then it says, when does it occur? At 15 seconds. Then we're going to go over 30 as well. So this has a function d of t that represents the jogger's distance in miles from their starting point over t minutes. So he starts and he runs a mile, rests for a second, runs another mile, rests, runs the 2 miles back. That was a very bad line, but we're gonna. So describe when the jogger is running away from the start. So when is the jogger running away from start? From where? It's basically when it's increasing. So where is that increasing at? The distance is increasing. So it's going to be from 0 to 8. Any other places where he's running further away from start? 12 to 36. All right, then it says, when is he returning? So when is he running back to start? Yeah, 44 to I think it's 58. Your graphs will also be bigger so you can see. Or
So how do we work? We just like.
yeah, this is this one. And that's that one. I should have made those 2 separate questions. I just didn't. Okay. Then it asks, when is the jogger stopped? So when is he stopped? And there we go. So from 8 to 12 and from 36 to 44. When is the jogger moving faster? What do I need to look at to know if it's moving faster? The slope. So let's look at our slope. Okay, here it's rise is 1, 2, 3, 4 over a run of 1, 2, 3, 4. So it's 4 over 4. Now over here though, our rise is 1, 2, 3, 4, but over 1, 2, 3. So which one's faster? The blue one, right? It's got a shorter run to get to a mile. So it is from 44 to 58. And it's because the slope is steeper. If you have a question that asks that, it will be very clear. You will not have to calculate the slope. Like, it will be like a comparison of this and this. Of those two, if that's what it looked like, when would he be running faster? 1 or 2? 2. Okay. Then it says, what does it mean if 2 points on the graph have the same y value? So what do the y values represent? The distance. So if he is at 1 mile twice, why is he at 1 mile twice? Not even because he stopped, because he's running away, then he's running back, right? So he's going to be 1 mile away from home. How many miles did he run in total? He ran 2 miles there and then 2 miles back. All right. Our last set of questions. What we did yesterday. So at the top of this paper, this is the one formula that is on this test. Okay? And it is A sub n is equal to distance difference times 9n minus 1 plus the starting point plus the first term. So we're going to do all of the odds. So the first thing we need to do is we need to find our first term. What is our first term for 31? 7. Okay, the second thing we need to do is we need to find our common difference. What is the common difference here? 5. And then we plug it in to the formula so we can find any term. So we do A sub n is equal to our difference times n minus 1 plus the first term. Then what does it ask us to find? The 22nd term. So we're going to plug in 22. So 5 times 22 minus 1 plus 7. What is that? Use your calculator. What was that? 112? That works for me. Is that what everybody else got? All right, now we're going to look at 33. So 33, again, we're going to start. What is our first term? What is our common difference? -7. So to set up for any term, we do our common difference times n minus 1 minus 16. Yes.
Do we have to keep writing that part, or can we just move
You,
on?
if it asks you to find that and that, so you have to do both.
What if it's actually for A12?
If it just asks you for A, then A12, then that's what you do. Okay, but from here we have to find the 8th term. But this is me telling you it's going to be like this on the test. Okay, so for this one, we're going to plug in 8. So -7 times 8 minus 1 minus 16. What is that going to be? And there we go. Go ahead and start 35 while I answer this. Yes, this is Miss Williams. Yes, ma'am. All right. So for 35, okay, what is our first term? -32. What is our common difference? +7. So our formula should be 7 times n minus 1 minus 32. And then what are we trying to find? So we're going to plug in 12. And when you plug in 12, what do you get out? 45. All right, then the last section is just to determine whether the sequences are arithmetic. If yes, find the common difference. So for 37, okay, what is the difference between the first two? What about from between the second two?
9.
The last two?
Are we gonna get a calculator on this?
Mm-hmm.
No.
Are those, is that arithmetic? No. Okay, to be arithmetic, it has to be addition and subtraction, or addition or subtraction, and it has to be constant. The difference has to be constant between every term. So for 39, what's the difference between -4 and -8? -4. From -8 to -12? -4. -12 to -16? So is that an arithmetic sequence? What's the common difference? All right, for 41, what is the difference between -11 and -13? -2. From -13 and -17? -17 and -25? Is that arithmetic? No, because it does not have a common difference. So you will need to finish this review, okay, most of the stuff that we left not done is stuff that we can do pretty quickly. It's like, is it a function, evaluate, and some arithmetic sequences. You are going to turn it in tomorrow, and we're going to take our test tomorrow.
Will you calculate?
You can use your calculator, yes.